how we calculate enthalpy, even when we don't have like our Q reaction. Okay, so this is a separate way of calculating enthalpy. And so what formula we're going to use, we have this delta H of the reaction, so this is the enthalpy of the reaction, should be equal to the sum of the enthalpy of the products minus the sum of the enthalpies of formation of the reactants. So this sigma here, that means sum of. And so we're going to take the enthalpies of formation of the products, sum all of those up, and subtract from it the sum of the enthalpies of formation of the reactants. All the enthalpy constants are in a given chart, which you'll find in your notes. They have to be multiplied by their coefficients. So you need to start with a balanced chemical equation. So hopefully we understand that now. And then we also need to pay attention to states of matter because the enthalpies of formation are going to be different depending on the state of matter that you have. Particularly if you're working with water, you really got to focus on what state of matter you're using. Okay, so these are the heats of formation values. They should be in your notes. You do not need to memorize them. Scientists, chemists always reference these charts, so definitely don't try to memorize them. Okay, so for an example, we have this balanced chemical reaction with hydrogen sulfide reacting with fluorine to give us hydrofluoric acid and sulfur hexafluoride. Okay, so our delta H should be equal to 2 times the enthalpy of formation of hydrofluoric acid plus the enthalpy of formation of sulfur hexafluoride. We're going to subtract from that the enthalpy of formation of hydrogen sulfide and 4 times the heat of formation of fluorine. Okay, so now we need to calculate delta H for each reaction here. And so remember, we're going to add up our reactants, we're going to add up our products. So what we need to do is figure out the heats of formation for each one of these. So I have, from the chart, the heat of formation of carbon dioxide gas is negative 394 kilojoules. Liquid water is negative 285.8 kilojoules. For methane gas, it's negative 75 kilojoules. And then oxygen gas, excuse me, sorry for the bell, is 0 kilojoules. Because any pure element is always going to be 0 kilojoules. So remember, we're going to do products minus reactants. So our products, CO2 and H2O. Okay, I have negative 394 plus 2 of these negative 285.8. Okay, and I'm going to subtract from that negative 75 and then 2 times 0, which is 0. Okay? So, got that going. So if I calculate that all out, I should end up with a negative 890.6 kilojoules. So that is my heat, or my enthalpy of my reaction. Okay? Make sure you include that label. It should always be in kilojoules. So now we're going to calculate the delta H for each one of these reactions. so what we want to do is write down these heats of formation for each one of these. Okay, so once again, there is a chart in your notes. I need to pull out my own chart, which should be in the appendices of my book here. Got properties of elements, solubility products. There we go, heat of formation values. Okay, so solid calcium carbonate. So I'm going to find calcium carbonate, and this says this is negative 1200, 6.9. Calcium oxide is right below that, and that is negative 634.9. And then we need to find carbon dioxide gas. Which is negative 393.5. These are all in kilojoules. So remember, we're going to do products minus reactants. So we have negative 393.5 plus negative 634.9. We're going to subtract from that the negative 1206.9, so that's like adding 1206.9. So if we do that, we should get 178.3 kilojoules. Okay? Anywhere on here where I have a pure element, I'm just going to put 0 underneath it because I know it's 0. Okay, methane, negative 74.6. CCl4, negative 128.2. NO2. Okay, we got NO2. $33.2, that's a positive one. Calcium oxide, we already put that up there. It's negative 634.9. Liquid water, okay, not gaseous water, is negative 285.8. And then calcium hydroxide, negative 935.2. Okay? So for this one, what we effectively have is negative 128.2 plus 74.6. That's an easy enough calculation to do. So we have 28 point. And we end up with a negative 53.6 kilojoules per mole, right? Because that's what we're given. This one is pretty easy because we have our products, our reactants are 0, so our delta H reaction should be equal to 33.2 kilojoules per mole. Actually, no, it should be twice that because we're making 2 of them. So that should be Very important. 66.4, right? Because we have 2 of those puppies. Okay, and then for this one, we've got our product, which is negative 935.2. We're going to subtract from that negative 634.9 plus a negative 285.8. So if we calculate that all out, we have negative 65.6 kilojoules per mole. Okay? I'm going to stop this here and record bond enthalpies later because they are now drilling outside of my classroom. So thank you for listening to how to calculate enthalpies using enthalpies of formation. We'll talk through bond enthalpies in the next video.